We are asked to find the ratio of triangle STD, which is this small triangle, compared to the entire parallelogram ABCD. At this point of time, it is important to note that since RC is 2 times of ST, the entire length RD should be 2 times the length of SD, which means here and here are the same length. So I'm going to split this and say that this is 2 units, this is 4 units, and the total combined should give you up to a total of 6 units. Okay, this will come in useful later. Okay, whereas this is 1 unit. Okay, given that this is okay, so what can we do now? There are several things we can consider doing. Number one is since we have just shown that these two triangles are similar, I can relate the small triangle to the big triangle. Units here and units here in terms of area. Okay, so let's try to write down area of small triangle STD over the area of the bigger triangle that is similar to triangle RCD. Since these two are similar, I can take L1 over L2 whole thing squared. This over this 1 unit out of 2 units whole thing squared. I will obtain 1 over 4. Okay. So the small triangle is 1 unit, or the big triangle is worth 4 units. Now, okay, the small triangle is not easy to relate to the entire parallelogram, but if I were to consider this big triangle compared to the whole parallelogram, they have one side that they share. They share a same side DC. Okay. Okay, instead of, we do not know the length. Okay, so instead of using the side DC, what else can you say about this triangle and the parallelogram? If I choose this 6 unit as my base, there has to be a perpendicular height. Okay, for this triangle, if I choose these 2 units as my base, there has to be a perpendicular height. So I will need to extend and find this perpendicular height, which happens to be the same as the perpendicular height of the parallelogram. So the triangle and parallelogram share the same perpendicular height, which allows us to relate the big triangle to the big parallelogram. Okay, so let's try. This part is a bit tricky. Let H be the height of parallelogram ABCD and also triangle RCD. Area of triangle RCD over the area of ABCD. Okay, triangle is half times the base, which is RD, times the height. Wow, the parallelogram is just the base AD times the height H. H and H cancels out, and I'm left with half multiplied by RD over AD, which is simply half multiplied by RD, which is 2 units, over AD, which is 6 units. So this gives me 1 out of 6. The relationship between area of triangle RCD over the entire parallelogram. Using these two, I can then try to combine my answers. Okay, so I have triangle STD is to triangle RCD is to parallelogram ABCD. 1:4, 1:6. Okay. Multiply by 4, I will obtain 1:4:24. And then using this, I draw a conclusion that the required ratio is, like the required ratio of STD is to ABCD. So area of triangle STD is to parallelogram ABCD is 1:24. Answer.